A home fuel cell is a residential scaled energy system based on fuel cell technology. It's one of the available technologies for micro-combined heat and power or microgeneration. A home fuel cell increases efficiency by simultaneously generating power and heat from one unit to be used on site within a home, thus eliminating heat loss and transmission loss. Combined heat and power fuel cells have demonstrated superior efficiency for years in industrial plants, universities, hotels and hospitals. Residential and small-scale commercial fuel cells are now becoming available to fulfill both electricity and heat demand from one system. Fuel cell technology in a compact system converts natural gas, propane, and eventually biofuels, into both electricity and heat, producing carbon dioxide as exhaust. In the future, new developments in fuel cell technologies will likely allow these power systems to run off of biomass instead of natural gas, directly converting a home fuel cell into a renewable energy technology. Specifics: high initial capital costs. As of December 2012, Panasonic in Tokyo Gas Co., Ltd. sold about 21,000 PEM farm units in Japan for a price of $22,600 before installation. Startup time: PEMFC fuel cell microCHP operates at low temperature and needs high-purity hydrogen. It is prone to contamination. Changes are made to operate at higher temperatures and improvements on the fuel reformer. SOFC fuel cell microCHP operates at a high temperature and can handle different energy sources well, but the high temperature requires expensive materials to handle the temperature. Changes are made to operate at a lower temperature. Because of the higher temperature, SOFC in general has a longer startup time, lifetime, around 60,000 hours. For PEM fuel cell units, which shut down at night, this equates to an estimated lifetime of between 10 and 15 years. Uses: most home fuel cells fit either inside a mechanical room or outside a home or business, and can be discreetly sited to fit within a building's design. The system operates like a furnace, water heater, and electricity provider, all in one compact unit. Some of the newer home fuel cells can generate anywhere between 1 to 5 kilowatts, optimal for larger homes or more, especially if pools, spas, and radiant floor heating are in plans. Other uses include sourcing of backup power for essential loads like refrigerator, freezers, electronics, computers, and wine cellars. Deploying the system's heat energy efficiently to a home or business hot water applications displaces the electricity or gas otherwise burned to create that heat, which further reduces overall energy bills. Retail outlets like fast food chains, coffee bars, and health clubs gain operational savings from hot water heating. Since it is in general not possible for a fuel cell to produce at all times exactly the needed amount of both electricity and heat, home fuel cells are typically not standalone installations. Instead, they may rely on the grid when the electricity production is above or below what is needed. Additionally, a home fuel cell may be combined with a traditional furnace that produces only heat. For example, the German company Viessmann produces a home fuel cell with an electric power of 0.75 kilowatts and a thermal power of 1 kilowatt. Integrated with the traditional 19 kilowatts heat-producing furnace, using the grid for electricity need below and above the fuel cell production. Environmental impact: because the home fuel cell generates electricity and heat that are both used on site, its efficiency is per definition 100%. This is in contrast to traditional or fuel cell non-domestic electricity production with both a transmission loss and useless heat, requiring extra energy consumption for the domestic heating. As noted above, however, the home fuel cell can in general not at all times generate exactly the needed amount of both heat and electricity, and is therefore typically not a standalone installation but rather combined with a traditional furnace and connected to the grid for electricity need above or below that produced by the fuel cell. As such, the overall efficiency is below 100%. The optimum efficiency of home fuel cell has caused some countries such as Germany to economically support their installation as part of a policy reacting to climate change. Installation. Home fuel cells are designed and built to fit in either an interior mechanical room or outside, running quietly in the background 24/7. Connected to the utility grid through the home's main service panel and using net metering. The home fuel cells easily integrate with existing electrical and hydronic systems and are compliant with utility interconnection requirements. In the event of grid interruption, the system automatically switches to operate in a grid-independent mode to provide continuous backup power for dedicated circuits in the home while the grid is down. It can also be modified to run off the grid, if desired. Current installations. 20 companies have installed Bloom Energy fuel cells in their buildings, including Google, eBay, and FedEx. The eBay CEO said to 60 Minutes that they have saved $100,000 in electricity bills in the 9 months they have been installed. Oregon-based ClearEdge Power has installations of its 5 kilowatt system at the home of Jackie Autry, Bay Area wealth manager Bruce Raber, and VC investor Gary Dillabore. Delta E Consultants stated in 2013 that with 64% of global sales, the fuel cell micro-combined heat and power passed the conventional systems in sales in 2012. Cost. Most home fuel cells are comparable to residential solar energy photovoltaic systems on a $1 per watt installed basis. Some natural gas-driven home fuel cells can generate 8 times more energy per year than the same size solar installation, even in the best solar locations. For example, a 5 kilowatts home fuel cell produces about 80 megawatt-hours of annual combined electricity and heat, compared to approximately 10 megawatt-hours generated by a 5 kilowatt solar system. However, these systems are not directly comparable because solar power is a renewable resource with basically no operating cost, while natural gas is neither. Operating costs for home fuel cells can be as low as $6.0 per kWh based on $1.20 per therm for natural gas, assuming full electrical and heat load utilization. Incentives. In the USA, home fuel cells are eligible for substantial incentives and rebates at both the state and federal levels as a part of renewable energy policy. For example, the California Self-Generation Incentive Program rebate and federal tax credits will significantly reduce the net capital cost to the customer. For businesses, additional cash advantages can be realized from bonus and accelerated depreciation of fuel cells. In addition, home fuel cells receive net metering credit in many service areas for any excess electricity generated, but not used, by putting it back on the utility grid. The database of state incentives for renewables and efficiency provides comprehensive information on state, local, utility, and federal incentives that promote renewable energy and energy efficiency. In California in particular, utilities charge higher per kWh rates as energy consumption rises above established baselines, with the top tier set at the highest rates to discourage consumption at those levels. Home fuel cells reduce customer exposure to the top-tier rates, saving homeowners as much as 45% in reduced annual energy costs. Market status. Home fuel cells is a new market and represents a fundamental shift in the sourcing of energy. An individual home fuel cell system installed in a U.S. home becomes a part of the bigger picture of U.S. energy independence. An ultimate benefit of home fuel cells will be to eventually create networks of microCHP systems distributed throughout communities and business parks. This self-generation of energy in a distributed generation approach that will secure and increase U.S. power generating capacity, enabling unused electricity to be sent back to the grids without having to add new power plants and transmission lines. Putting a home fuel cell system into homes has the potential to get people off the grid, play a significant role in energy efficiency, and reduce U.S. dependence on foreign energy imports.